Alright, these are the notes for review 2. Our first equation is in standard form, which I know x is equal to negative b over 2a. So I plug in a negative b, which would be negative 4 divided by 2 times a. Negative 4 divided by negative 4 is a positive 1. So x equals 1. Then to find my y, I plug 1 in. So we get negative 2 times 1 squared plus 4 times 1 minus 4 equals negative 2. Those represent my vertex, my first number, then my y. So I put my plot at over 1 down 2. Now parabolas go by 1, 3, 5, but because there's a negative 2 in front, it's going to go by negative 2, negative 6, negative 10. Down 2 over 1. Down 1, 2, 3, 4, 5, 6 over 1. If you forgot how to graph these, just make a table and plug in negative 1, 0, 1, 2, 3, 4. Just plug in the values for x into the equation, and then it will tell you. So like if I plugged in negative 1, you'll get out a negative 10 with your calculator. If you plug in a 0, you'll get a negative 4. If you plug in a 1, you'll get a negative 2. If you plug in 2, you'll get negative 4. Then you'll get a negative 10, right? So you'll plug values in and then you can plot the points if you forgot how to use standard form. Our y-intercept is where it touches the y-axis, and it touches right here. That point is 0, negative 4. Now I want the x-intercepts, but the x-intercepts, my graph does not touch, so that means they're imaginary. That means to find my root solution 0 or x-intercept, I have to plug it in to the quadratic formula. So I have negative 4 plus or minus the square root of 4 squared minus 4ac all over 2a. Notice I just plug the numbers in, right? There's no x's in here. Negative 4 plus or minus the square root. I'm going to plug all of these in. 4 squared minus 4 times negative 2 times negative 4 equals negative 16 over 2 times negative 2 is negative 4. I simplify the root. Root 16. 16 breaks down to 4 and 4, or you can just check. The square root of a positive 16 is 4. Now because I squared a negative, I have to have an I on there, an imaginary or complex. Divide by negative 4. 4 goes into all of these, so I reduce it to 1 plus or minus 1i over 1. And if you really don't want that there, you can get rid of that 1. Those are our roots. If you want to separate them, you do not have to. It would be 1 plus I, and the other one would be 1 minus I, because we don't need the 1 in the denominator if we don't want it there. It's just a placeholder. Domain are the x values. So when I look for x values, the domain is true for all directions because the arrows continue going left and right. So negative infinity to infinity. Now the range, as I scan my graph up, my graph starts at negative infinity and it stops at negative 2. So my range is from negative infinity to negative 2. negative infinity to negative 2. All right, let's try example 2. We have A, B, C. The x is equal to negative b over 2a for the vertex, not the x-intercepts, the vertex, equals, two negatives make a positive 4 over 2 times negative 2. 4 over negative 4 is a negative 1. I plug that in to see what I get for y. Negative 2 times negative 1 squared minus 4 times negative 1 minus 1 equals 1. So there's my vertex, negative 1, 1. Now, because my graph usually goes by 1, 3, 5 when it's squared, I needed to multiply it by the a, and I get negative 2, negative 6, negative 10. 1, 2, 3, 4, 5, 6. And remember, if you do not remember how to graph it, you may always make a table. Ooh, it's a little lopsided. Now I need my y-intercept. Y-intercept is when it touches the y-axis at 0, negative 1. My x-intercepts, this one is the one you guys are not going to like because we don't know where it touches. It's not on a whole number. So we need to use the quadratic formula. So we get negative 4 makes a positive. Negative 4 squared minus 4, negative 2, negative 1, all over 2a. 4 plus or minus the square root. I'm going to see what the inside will equal. Negative 4 squared minus 4 times negative 2 times negative 1 equals 8 over 2 and negative 2 make a negative 4. 8 I can reduce. I'm just going to do it on the side and see what it reduces to. 4 times 2. 2 times 2 times 2. 2 can leave, but 1's left inside all alone. So 4 plus or minus, that root 8 became 2 root 2. 2 goes into all of those numbers, so we get 2 goes into 4 twice, 2 goes into 2 once, 2 goes into 4 twice, and the root tags along for our radicals. So these represent our x-intercepts, which are also called roots, solutions, or zeros. So whenever you see any of those 4 vocabulary words, it means to solve for x. Domain is negative infinity to infinity, and the range goes all the way down from negative infinity until it stops at 1 this time. So negative infinity until 1. Problem 3. We're going to graph it. We have A, B, C, and standard form for the vertex. X equals negative b over 2a. So I'd get 12, because 2 negatives make a positive 12, over 2 times 2 is 4, which equals 3. Y equals, I plug the 3 in. 2 times 3 squared minus 12 times 3 plus 21 equals 3. That's nice. 3, 3. Over 3 up 3. There's our vertex. 1, 3, 5, but because it's a 2, we have to double them by 2, 6, 10, and it's going positive this time. Up 2, up 1, 2, 3, 4, 5, 6. My y-intercept, it doesn't show on my graph, so if I want to find it really quick without having to count up 10 and over, which you could, I mean 11 plus 10 is 21, so you could say 0, 21. Or you can just plug 0 in. Cancels out, 0 and 12 cancel out, all that's left is 21. The x-intercepts don't show up, which means they're complex, so I need to substitute them in. So I get 12, because two negatives make a positive, of negative 12 squared minus 4ac all over 2a. 12 plus or minus, I simplify the inside. Negative 12 squared minus 4 times 2 times 21 equals negative 24 over 4. I'm going to simplify this on its own. So 12 breaks down to 2 times 12. 12 breaks down to 2 times 6. 6 breaks down to 2 times 3. And I can't break them down anymore. The 2 can leave. When I take out a negative 1, it becomes an I. And the 2 and 3 are left inside because they don't have pairs to leave. So we have 2 times 3 is 6. 12 plus or minus 2i root 6 over 4. 2 goes into all of these values, so 2 goes into 12 6 times, 2 goes into 2 once, and 2 goes into 4 twice. And the root 6 hangs out on the end without dividing it. Domain, for the x's, it is continuous, negative infinity to infinity. And for the range, I check it starts at 3 and continues all the way up to positive infinity. No lights. All right. Now, for problem 4, we have it in vertex form. These ones are nice because you just take out the vertex. Negative 4 becomes a positive. The outside value stays the same. Over 4, down 4. My rate goes by 1, 3, 5, but because of the negative, they need to go down. Down 1 over 1, down 3 over 1, down 1 over 1, down 3 over 1, in both directions. All right. For the y-intercept, we can't see it. If you want to keep following the pattern down and go by down 7, down 9, you can to find it. Or you can just plug in a 0. Plug in 0. So we get negative 4 squared. 4 squared becomes a 16. And then minus 4, 16, and 4 make negative 20. For my y-intercept, my vertex, we already took out 4, negative 4. And the x-intercepts, guess what? You're gonna not have to find them, but they should be complex. So with the vertex form, you can just say that they're complex and be done. Because we don't have it in standard form and we're just going to leave it. Alright, we have vertex form again. I take out the 2 and it becomes a negative. The 1 stays the same. Negative 2 up 1. My pattern is 1, 3,